What is up, Twitch and YouTube? We are here with day 8 of Advent of Code. We're going to be coding our solutions in Python, and I'm going to try and aim this at low-level Python devs. So not professional level, hopefully, but sometimes these tasks bring in some really complicated concepts. Yesterday was trees and recursion, stuff you would sort of expect in like a Google-style interview, not something you would expect in a normal day-to-day job. So it can get a little bit tricky, but let's see how we go. Today we are on day 8 of Advent of Code, and our code will be available at repl.it/@josephone1993/day. It'll be in the chat, don't worry about that. It's too long for me to read out loud. Okay, let's get started. Day 8, handheld halting. Your flight to the major airline hub reaches cruising altitude without incident. While you consider checking the in-flight menu for one of those drinks that come with a little umbrella, you're interrupted by the kid sitting next to you. Their handheld game won't turn on. They ask if you can take a look. You narrowed the problem down to a strange infinite loop in the boot code. Your puzzle input. So, always good to have a look at what we're playing with here. So it looks like list of commands and numbers. Looks like there's only 3 or 4, but we'll see. Strange infinite loop. The boot code is represented as a text file with 1 instruction per line of text. Each instruction consists of an operation, ACC, JMP, or NOP, and an argument, an assigned number, so it might be +4, -20. ACC increases or decreases a single global value called the accumulator by the value given in the argument. For example, ACC +7 would increase the accumulator by 7. The accumulator starts at 0. After an ACC instruction, the instruction immediately below it is executed next. JMP jumps to a new instruction relative to itself. The next instruction to execute is found using the argument as an offset from the jump instruction. For example, jump 2 would skip the next instruction, jump 1 would continue to the instruction immediately afterwards, so, oh no. I was going to say I'll have a look for an example, but maybe not. So jump 10 will go back 10, I suppose. Yep. NOP stands for no operation, it does nothing. The instruction immediately below is executed next. For the following, we have no operation, increment the accumulator, jump 4 steps down. So 1, 2, 3, 4. Increase the accumulator to 1. Jump -4. 1, 2, 3, 4. Increase it to 8. Jump -3. 1, 2, 3. Increase it to 9. Okay. Did I get that wrong? Well, it looks like it ends at some point, so that's okay. Yeah, it would end after this one, would it? 1, 2, 3, 4 +3. I don't know. There's nothing. Accumulator is increased. Accumulator 5, jump continues back. This is an infinite loop. With this series of jumps, the program will run forever. The moment the program tries to run any instructions a second time, you know it will never terminate. So we could sort of store whether we visited something before. Immediately before this program would run instruction the second time, the value in the accumulator is 5. Run your copy of the boot code immediately before any instruction is executed the second time. What is the value in the accumulator? Okay, so let's start straight away with this text file, puts.txt, and same as usual, read Python line by line. Oops. Uh-oh. This isn't my usual code. Read Python file line by line. Cool. And let's read that in as our data. And let's print our data. So we should have individual lines. And we change this to puts.txt. We should now have individual lines from our file, so we can iterate over those lines for line in file in data print line. It's not really going to help us because we're going to have to, we can't really trust that we're iterating through it one at a time. We're just going to have to try and I guess we're looking for like while an operation is not received. So while, let's do no is duplicate. That equals true, equals false. And then we can say while not is duplicate. So while we have not yet found a duplicate, then we want to iterate over the line and print each line at a time. So let's start with line 0. So if it's NOP, how are we going to do this? Data 0. And we can do int plus 6. Yeah. Okay, so we can use this int function to convert plus or minuses just to actual numbers we can use. We're going to have a index, which will be equal to 0. This will be what we iterate over. So we're going to access the first one here. Data equals index. So data index, that will get our NOP 0. Then we're going to say operator equals data index dot split on a space, so that will split these, giving us NOP and plus 0. And then the other one we want, I don't know, number. So now we can print operator, and print our number, and we should get oh, I keep writing JavaScript while not is duplicate. Can't use that. Okay, and it will just run forever. So let's make sure we end it for now. So let's just say is duplicate equals true. So now if we run it, it only runs once, we get NOP. And I actually want to convert this to an integer. So it might make more sense just to get the 0 here, and for the next line, get just the number. 1 and convert that to an integer. It should give us a number and an operator, and it should just say 0 instead of plus 0. Cool. So if it's no operator, we don't need to do anything, we just increment the index. So that's our first bit of logic. So if operator equals NOP, then we can just say index equals index plus 1. I'm going to have elif operator equals acc. We're going to increment our accumulator, which we don't have yet. So we're going to say accumulator equals 0 as well. If we do that, we're going to get operator equals operator plus 1. And we also want to increment our index. That should be accumulator, not operator. Okay, and then let's just do that for now. So instead of immediately saying is duplicate is true, don't really need to worry about that for now. But it does eventually get stuck on that last one. So we should see it if I don't run it for so long. Nope, okay, it's going too quick. Let's say if index equals 10, then we will set is duplicate to true. So it should only do the first. Oh, while not is duplicate. Is it not reaching that because it's going to jump? Set it to 4 then. The heck's going on here? If index is 4, how many? should be reaching for. Let's print the index. Index is definitely reaching for. Or something's. Or is it only reaching 2? Does ACK not exist? What's going on there? Maybe it's only getting to 2 because it's only hitting the. There's only one NOP. Okay. Well, we need to stop this running so many times. At the moment, we always need to increment our index, so we actually don't need that first one. Actually, no, we do. We will when we get to the accumulator anyway. When we get to the jump ones. So why does it not get to... Oh, because it reaches a jump, so it doesn't know what to do, so it just sticks to jump 4 forever. That makes sense. elif operator equals jump, then we're gonna change our index by whatever the jump is. So index equals index plus number. That might be a positive, that might be a negative. Okay, and then now we want to say, so we need to store which commands we've already seen. So I could just store the indexes we've had so far, and then once those are found, we're okay. So if we say indexes accessed equals a list, then at the start of each loop we can say index equals index.append whatever the index is. That needs to be index accessed. So here I'm going to print the index, and I'm going to print the index accessed, and we're going to see what that does. So we access the first item, we put it in there, we access the second item, put it in there, access the sixth, seventh, third. So you want to say if index is in index accessed, then we can set duplicate to true. If index in index accessed, I think that's right. So if I do 1 in 1, 2, 3, true. If I do 4 in 1, 2, 3, false. Okay, that looks good to me. Oh no. So I need to check this at what point. Why did it end straight away? Because index is an index accessed, but that's because we just added it there. So I need to append it after that. Okay, that looks good. So then when we finally get to the end, we need to print out an accumulator. We get 3, but that's not correct. It should be 5. So what are we doing? Nothing. Incrementing the accumulator, jumping 4 forwards. So that should take me to 1, 2, 3, 4, accumulator plus 1, which it does. Then jumping 4 backwards should take me to 1, 2, 3, 4, accumulator 3, which should be 5. And jumping 3 backwards, 1, 2, 3. And then we've already accessed that one, so it shouldn't be adding. So the accumulator is 3. Am I not adding it together. Needs to be accumulator plus number, not accumulator plus 1. Cool, so we got 5. So we're looking good for this test case anyway. So let's try it with the full input. My confidence is low, but let's see what happens. Okay, we get an answer. I can't believe it. Another star coin. That's 14 star coins. We're so close. We're almost on holiday. We just need another 36 and then we can get to go on holiday. I can't believe it. Alright, let's get into part 2 then. Let's see what happens. So part 2, that was way too easy, I think. So something bad is going to happen here. After some careful analysis, she believed that exactly one instruction has been corrupted. Somewhere in the program, a jump is supposed to be an NOP, or an NOP is supposed to be a jump. Okay, so let's see. So I guess we could have a no operator with a number, so one of those might need to be something else. Jeez. This program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. By changing exactly one jump or NOP, you can repair the boot code and make it terminate. If you change the first instruction from NOP 0 to jump 0, it would create a single instruction infinite loop, never leaving that instruction. If you change almost any of the jump instructions, the program will still eventually find another jump instruction and loop forever. If you change the second to last instruction from jump to NOP, the program terminates. The instructions are visited in this order. After the last instruction, the program terminates by attempting to run the instruction below the last instruction in the file. With this change, after the program terminates, the accumulator will contain 8. Okay. So let's take this input again, and it will terminate. So we need something that's going to iterate over this list one at a time, change the value of NOP or jump to its alternate. So def flip command, and that can be a let's just take a list, I guess. And let's take a string. Instruction. And then we're going to do instruction.split. No. Bye bye. Okay. Instruction.split. Give us so we can practice this one actually just on its own. So flip command. That should be NOP plus 0. And that should return jump plus 0. Okay, it doesn't do anything yet, that's fine. Instruction.split. So new equals instruction.split. If new 0 equals op, not, then new 0 will equal jump, else, because there's only one case, new 0 will equal not. Then we need to join them together, return new, it's not, strings dot join. Don't actually need to split anything. I guess I do. I could just replace them, but I would still need some sort of if statement. So I think that might be alright. Join new. Okay. So now if I call this get jump, change it to jump, and we could just do, otherwise it'll leave it, right? So we could just hand it an accumulator and it will just leave it. Oh, it won't because my... Okay, let's change that to elif because then we can just have a sort of safer loop happening there. So elif new equals jump. Okay, and then I'll paste. So let's test this out again. So we got that to jump. Jump should flip to not. Oops. And anything else should be left as it is. So if we give it an accumulator instruction, it'll stay the same. Cool. So now what we can do is iterate through basically running this code again. So let's wrap this up in a function as well. Def check terminate. Does it terminate? And that's going to take a list data. Yeah. Instructions. I'm going to indent that. We might need to move all of those globals inside there as well, because those are going to need to get overwritten each time we run this. And we need to return, well, we're going to need to return the accumulator, but we're also going to need to return so for now let's just do returns, return false, and then that's not available, but this function will be, so we can call does it terminate, print does it terminate, and pass it data. So it should return false now, but still run over everything, which it does. Cool. So how are we going to check if it actually gets to the end of the list? I guess we could check if the length of our index accessed grows bigger than the list. It's a bit cheeky, but we could give it a go. So if index accessed is greater than length index accessed is equal to length instructions, and we need to make use of our instructions now instead of data, equals length instructions, then when we're done, return true. So let's return the accumulator. So it's false now, but if I change jump this to not, should end and return out accumulator. Okay, list out a range. Yeah, that makes sense. I guess it could. So what has it jumped to? Index error, list index. Does it say what list index it's looking for? It's this instruction that's complaining about actually. Okay, I need to print some stuff because I can't read what's going on anymore. Print index. So index 8 should be 2, 3, 4, 5, 6, 7, 8, 9. So that should be okay. What's it complaining about? Line 14. Operator instructions. Did I make a typo? So why doesn't it like that? Maybe this character doesn't exist there. Be odd. And 37 print, so that's calling, that's going in there. So this is the line it's complaining about. So it can't seem to get. If I call this on NOP, was it NOP? -4. Oops. NOP -4. It gets an op. List index, instructions index. So let's print instructions. I don't see why that would fail. Let's print instructions 8 actually. So is it reaching this point where this index is slightly larger than I realize it is, maybe? So maybe it's printing a 9 here. Yeah, that's why. Okay. So that one doesn't exist. If you could just say if index equals length data +1, length instructions +1, then we could return true here. Return the accumulator here. That should stop it going in there. Oh, line 16. Oh, we don't need the +1. Okay, so that works. So what's the accumulator at this point? Value 8, which is what I've got here. So that's working. So now we need to find the one that we change that will fix this for us. So we can call, probably need to get rid of a lot of these prints. So what we can do is for, okay, copy, let's call it instructions copy equals data this, so that will make a copy by value instead of copy by reference. For line in data, we're going to make a copy of the entire data set. We're going to flip the command for each line, flip command line, and then we're going to command line. Will that actually update the line? No, it will return the original line. So we need to say line, that's not going to do anything, is it? Data, no, let's try it. Line equals flip command line. And let's print line. Let's print the whole data set actually, print data. So nothing for line in data, which is everything. We're not updating the line, which makes sense. We don't have the index of the line, do we? I don't think we can even assume that these lines are going to be unique as well. So let's do let's use indexes instead. So let's say for index in data range len data. And then let's say line index is equal to flip command line. It's not line index, data index. Data index. So that should flip each one now. So we get one where the first one is changed. Ooh. I'm using data instead of our copy. So now we get none of them have changed. First one's changed. First one's changed. First one's changed back. Doesn't look reliable. No, this one's changed to not appear, but on the 1, 2. Okay, something's not quite right there. Am I accidentally updating the data object maybe? What's happening at the end there? They seem to have lost some letters in the first one. So you should be seeing some sort of diagonal changing going on. But something seems to be printing twice. Have I got any other prints that might be confusing me? Just the answer. That shouldn't be a problem. That's at the bottom. So for index, let's print index. So index should just be 0 to 8. Oops. 0, 1, 2, 3, 8. Let's print instructions copy index. See what that does. Hey, it looks like it's working now. Was I looking at something wrong there? So we got the, let's clear that, run it again. So we got position 1 is replaced with jump, position 2 is the same, position 3 is replaced, 3 is the same, position 5 is flipped. Okay, it looks okay to me. So now we can just call this on everything, print answer. That will give us an answer 8 every time. Why? It shouldn't be 8 every time, it should be false most times. It's not because I fixed it, didn't I? So it needs to be like that, and then there should only be one answer, which there isn't. That's not good. So there should be an instruction copy. It's because I'm not sending it the copy, I'm sending it my data. So we've got one answer 8 here, which is the second last run when it flips that. So that's looking good to me. So there's going to be loads of running here, so we're going to need to tidy up. Can't afford to print our index each time. We can't print that. We can't print the whole thing. We can print the answer, does it terminate, but there's going to be hundreds of them. Oh, I saw it. So really we only want to print this out when there's something that isn't false, but we can see here it's 1016. If it works, I'll be impressed. Not that impressed though. Here we go, another star coin. That's 15 star coins, everybody. We did it again. I can't believe it. 36 minutes as well. That one had a high probability of going wrong, I would say. But fantastic work, everybody. That is day 7. That was yesterday. That is day 8 of Advent of Code. Throw to that. Thanks for watching Screen.